Welcome everyone. Today we have our new episode, and this episode is very important for automation science and engineering. We have our world famous speaker, Professor Edward, Professor Rob, and Mr. Adam. I think we have another speaker. He will join soon. And I want to start these discussions, especially automation is very important. Professor Edward, how do you want to analyze today?
Ah, well, thanks for this interesting topic. In one sense, this is just part of the broader issue of the evolution of production in industry and in the world. When you talk about automation, I mean, automation goes back to over a century. Henry Ford, is in the United States in the 1910s and 20s, was known for his revolution in how to produce goods, how to produce products, specifically automobiles. The idea of an assembly line with interchangeable parts, and the product goes down the assembly line, and at one station they put in the chassis, and another station they put in the shell of the car, and the next one they do the doors, and they put the engine in, and then they put the carburetor in. So, I mean, and that's one of the things, of course, that really brought down costs. And Henry Ford's whole vision was that he could produce an automobile that could make profits for his company by selling them at a price low enough for more Americans to buy them. Millions and millions of Americans, of course, ended up buying cars. Interestingly enough, he had, for the time, one of the highest wages because he needed to keep skilled workers and workers who were, who wouldn't get so bored on the assembly line they would leave. So again, this goes back for well over a century, and you could even get into the Industrial Revolution a century before that relied on automated production. But I think what we want to look at is what's going to be happening in the future. And again, robotics have been in factories for many, many decades. I remember one of my first trips when I was working in the late 80s at the Heritage Foundation was to Detroit to tour automobile factories, GM in particular, and to look at how they were innovating with robots to try to keep quality control up and production costs down. Unfortunately, it didn't work very well. They had to go through a lot of changes to really automate. But what you're going to see in the future, I think, is a couple of things. First of all, more and more, of course, automation is going to be integrated into the production of pretty much everything. Quality control is going to be very important. Also, customization is something that's going to be important. In other words, if you're looking at countries in Asia Pacific, they don't care about how customized they get a product. They care about just getting the product in a lot of countries. In Bangladesh, it's pretty much we want to get the product. We don't care about customization. But what you're going to see, especially I think in the West, in the developed countries, is certainly would go for Singapore. Obviously, South Korea is one of the cutting edge countries on this sort of thing, is custom production with 3D printers and things like that. The ability to change very quickly, not only in terms of being able to customize products, but in terms of market demand, where when they see that, for example, perhaps people want cars that do a different kind of thing. Maybe flying cars are going to be the big thing in the future. I think it probably is going to be, or whatever. You're going to see a lot of this, the ability to change very fast the production process. And so I think that's the sort of thing we're looking at. And if I could make these predictions, I would probably be very rich and probably would be doing your show from a mansion as opposed to my humble home here. But I think that that's the sort of thing you're going to see in the future, and especially with integrating artificial intelligence into more and more into the production process, and to change the face of production, where we're talking about the emergence of the Internet of Things. By the end of this decade, there will be something like 500 billion sensors of every single type in our world. And so having a product might not be as important as just having the access to some kind of a service, or instant access, perhaps through 3D, through holograms, and so forth. So anyway, it's an exciting topic, and if you're in the Asia Pacific area, hopefully you guys will be on the cutting edge as well as countries like the United States.
Thank you. Professor Rob, how do you want to analyze this automation? And most important thing is that because most of the cases, because we have many audience from developing nations, if you share some analysis from inside industry, the cost and financial investment required for automated how we when we plan for automations and we plan for infrastructural development, if you give a specific guideline, because we have many industrial people, those who regularly observe our show from developing nations, they have industry but they love to move for the automation. Hello.
Okay. Well, as Edward pointed out, we've been working on automation for quite a while. Actually, started with Winchester. The technologies advanced from when it was largely manual products coming down the line and people doing assembly to numerical control machines that were at least initially isolated and operated under programs that were connected directly to them, to now full-on networked manufacturing sites that are highly use robots very highly. Sorry, I'm still waking up. In fact, one of the interesting things is we watched Tesla come forward because they went farther than anybody else to automate the lines, was how much quality control they had. Because you would think with robotic lines you would have no quality control problem, but the issue was the people that they had running the factory were not experienced in building automobiles, and that they were technically competent, but they had no experience on manufacturing line. At least not a critical mass of them didn't have experience on the manufacturing line, and that's what has and continues to hamper Tesla's quality efforts, is because they lack the competency, the deep competency of that often created over years of experience on manufacturing line. And and it's kind of interesting because you watched how when Tata took over Jaguar from Ford, they actually brought in a bunch of people from Mercedes to run manufacturing. And the point of that was, of course, Mercedes has been doing automotive manufacturing since the beginning of the car, and that experience allowed them, at least initially, to change Jaguar's quality reputation, which really wasn't all that good, even through when Ford was running it, to something quite a bit better for a while. It's dropped off a bit of late, not sure why. But the promise of being able to do highly automation is, if it's done correctly, you get higher quality, you get higher throughput, you get less waste. Now, I did mentioning Mercedes. I did a factory tour a few years back of a Mercedes plant in Germany, and I was less than pleased. And it kind of showcased what can happen when automation and labor unions bump heads. Germany has relatively aggressive labor laws, and so putting in automation that removes jobs is problematic for them. So they almost always have to leave people involved in the process. And so I observed the line, and what I was seeing initially was one they showed me a process they were very proud of, because it was computer run, and what it did is it shined a light on a box where a person pulled the part out of the box, and then it would shine a light on another box where he would put the part in the box, and that other box was going to go to a particular car. And so what I observed was, well, the light shone on the box, he found the part. When it shone on the other box, he got the part, but it didn't. There was no explanation of how he was going to put the part in the other box, and often it didn't fit. And so you see this poor guy struggling to try to fit these parts into boxes one at a time as he's going through. It really kind of reminded me of a bad joke using monkeys, but because it wasn't efficient at all, and it wasn't truly automated, because you had a guy doing something that a robot actually should have been doing. Then I went to one of the main lines for one of the very high-end cars, and next to the line was a place where you put rejects. And for whatever reason, while the line's moving, they called a meeting, and so a bunch of guys left the line and went to the meeting, but the cars continued to move through the line, and so now the reject area was starting to fill up with cars because they weren't having the work done on the line. And of course, all of that was going to now have to be done individually off the manufacturing line to fix the car. Once again, one of the most inefficient processes I've seen, but the quality is actually very good. So here we took a hit on production volume. They maintained quality, but really for a company that's supposed to be renowned for their manufacturing prowess, I was less than less than excited. And I just bought a Mercedes, and as I left the factory, I was going, "Yeah, this is probably going to be my last Mercedes," because I don't want to think what's happening on those lines now that they're going through. And don't get me wrong, American car companies were kind of famous for a long time with having cars coming out with soda cans in the wheel wells and stuff, because they weren't monitoring quality very much yet either. In fact, my biggest experience of a line failure was at IBM. When we were building storage equipment, and we were getting 100% failure rate at the end of the line, which meant every single piece of equipment that was coming off was non-operable. And some idiot had come through with the idea that it was cheaper to discard the equipment than it was to refurbish it. So we were just sending this stuff off to landfills. It was the most insane thing that I'd ever seen. And the mistake that was made was on the quality checks on the line. Every quality check checked the process that had just occurred, but they didn't do a full check until the end of the line. And on the line, one of the processes was breaking a prior process. So what it did was correct, but it broke something that a prior process had done, and then that wasn't caught until a comprehensive review of the product at the end of the line was done, and that's why the product failed. The fix, by the way, was to do comprehensive tests about every quarter of the line, so you could catch a problem like this and correct it before you had an issue. But I want to point out, this thing went on for weeks, putting out hundreds of pieces of equipment that were going directly to landfills. As an auditor, I was just flummoxed. It can really show you the kinds of really crazy stuff that goes off in manufacturing. Right now, the big movement on manufacturing is digital twins and using the metaverse. BMW is probably the leading advocate of the process, and what they do is they create a factory in the metaverse, a full digital twin, and then they test the robotics and the robotic program in the digital twin, so much of the parts movement of BMW is now robotic. By the way, I should point out, in Japan, the most interesting place I went to was Lenovo's automated warehouse, where all the parts were pulled automatically using these robots and these pallets that were rushing around the warehouse. I still want to ride one of those things, but they said it was slightly unsafe. But it was just fascinating. But the point is if you're going to do it now, if you're going to build a place now, the leading edge, the cutting edge is digital twins and heavy robotics for everything from parts movement to assembly. They're linked. You do have to think about security, because of course, if a factory like this gets breached, you're going to have a whole world of problems. So the security is incredibly important because of the speed these machines are running. And also, you've got to really watch how people move through plants like this, because even though a current generation of robots are supposed to sense people and stop without running over them, in the past we have had issues where people have gone where their equipment's operating and they lose an arm or they lose a leg or whatever. And not only does it bring down the line, it can create significant labor problems. And of course, if you're the person that it happens to, it's not exactly the best day you've ever had on the planet. So you have to consider safety, you have to consider security, and remember to use things like digital twins in the metaverse to test everything in the virtual world first, thus reducing your costs when you actually build the plant and better assuring a positive outcome.
Thank you, Professor Rob. We have our new speakers, Mr. Dan. So we are discussing on automation science. So can you please analyze some points like based on automation science and engineering? And then I request our honorable speaker, Professor Hung Chiang, for explanation on automation engineering. I know he has many inventions and many copyright and patent he has. He will discuss with our audience. Mr. Dan.
Yeah, I appreciate being invited to participate today. I'm looking to bring open source and automation and GIS to Thousand Oaks, California, where I'm going to be on the ballot again in 2020 after having run twice before for city council. And I'm really running to put transhumanist ideas into the Overton window. But yeah, as far as, I'm involved with the Conejo Valley maker space. The maker movement is really a fundamental reboot, so to speak, of the Industrial Revolution. It's kind of taking from distant factories and moving it to purpose-built home desktop-built products, because the amount of tools that are available now for rapid prototyping is really going to be a disruptor to the traditional automation engineering world. And so I'd like to see a library of open source engineering, 3D printers and laser engravers, and those kinds of things. I think every city should have a library where you can check out those tools, and assuming you're properly trained on how to use them. But that would be part of my transhumanist platform for Thousand Oaks, California. And I like what Elon Musk recently said is like the best part is no part, and every design is wrong. It's just a question of how wrong. He was doing a tour of his Starbase on YouTube the other day. I thought that was a great pull quote. So.
Thank you, Professor Han. So how do you want to analyze? I know you have a lot of interesting things, as well as you love to dance. I'm actually a big fan of your dance. Anyway, so how do you want to analyze today's topic, and what do you want to share? And one point, Professor Rob, personally, he called me, we discussed, and he really appreciate how you some point criticize him, and this is the first time he get this experience, but it's mean that he has a very broad minds to take everything positively. So thank you. I'm just want to share with Professor Rob, because the last sessions we have something, but this is we are open-minded. We love to learn from each other. So Professor, how do you want to analyze today's topic?
Yeah, well, anyway, I appreciate the criticism. Actually, I don't get criticized too often, but actually almost never, and because I don't go out and show myself too much, maybe, my professor, Milton Friedman, and Sadeh, Rafi Sadeh got criticized, openly, and publicly. So they actually suffered, Milton Friedman got heart attack. So basically, it's not, I'm glad I had some experience. I don't mean anything personal, but, that part I'm not, I actually appreciate, you see. So basically, let me open this up, just get to this. If you think you have enough, then you tell me that I need to stop. You see, let me give you one instance, show you where I stand. Okay, Rockwell International, the world leader in robotics, once, after talking to me, they used the title, the name, Complete Automation Laboratory. Okay, I just searched. After a few years, I searched and I found this thing. I say, wait a minute, we have a completeautomationlab.com. We got a website. So I gave them a call. I wasn't going to accuse them of copying from us. But after the call, they had some internal discussion. They immediately terminate using the name. Okay, then now I tell you, I can claim that Pole Science is the absolute world leader in automation. Okay, let me tell you, let me explain this give some introduction. Automation means mechanization. In other words, let machine do the work. That's automation. Okay. Automation of the mind means computerization. First software, then hardware. Okay, we program in software, in hardware, then we automate the mind. The speed of software will go up 1,000 times when they turn from software to hardware, basically, roughly, up to 1,000 times. Okay, let me tell you, little knowledge is a dangerous thing. Okay, here there's a real typical example. Partial automation in software causes short-term gain and complexity crisis in the future. Okay, in other words, it's a net loss. Okay, all the software we write today eventually will not have enough people to maintain it manually. So they will lead to complexity crisis, which our people already see a great deal. Okay, today's all these hackers, software hackers, they are part of this complexity crisis. Nobody can control them. Okay, Pole Science, of which I'm the founder, solved and disclosed in a patent the solution of complete automated software in 19 patent in 19 solved in 1986 and the patent in 1996. Complete automation is a main characteristic of life. Complete automation is the solution to unlimited complexity which characterizes life and DNA. Life science with DNA and protein resembles computer science based on logic more than science based on experimentation. Okay, this is a big statement. In other words, all the life scientists today are doing things incorrectly. They are using the wrong method. Okay, they're using the scientific method of empirical verification, which one of my professors, my mentors, Paul Feyerabend, he's against. He wrote a book called Against Method. Okay, what method? The scientific method. So in other words, the scientific method should not be used for solving all kinds of problems. It can only use for solving scientific problems. Today, I even have questions regarding, using it for scientific methods. So for scientific problem, so my student had to submit the award application nomination for lawless physics. In other words, physics without laws. Okay. All these laws are very strange. Okay, where they come from, nobody knows. There's no reason behind it. So lawless physics. Okay, example of lawless physics are Maxwell, Boltzmann, his student of Maxwell is Boltzmann. Boltzmann is really the person who I studied under. His subject is what I study under. I'm a plasma physicist. I formulate the foundation for plasma physics with generalized phase space. Okay, Boltzmann use a phase space with only spatial and velocity. Okay, I make it into generalized. So basically, these people they don't tend to use arbitrary laws. They derive everything from mathematics. Okay, so there is a question whether it's possible to derive everything from mathematics instead of try to come up with some kind of natural constant or something. Even the natural constant for speed of light, it's kind of like mathematical. It's getting close to mathematical. In other words, you have what kind of media, if a rope, it will propagate in certain speed. If it's a wave, a tidal wave, ocean wave, it propagates in certain way. But in the medium of vacuum, light propagates in certain way. So basically, there is this possibility of base everything on mathematics instead of on laws, arbitrary laws. Say to create logical life science or theoretical biology, the current society needs to overcome the technical barriers of complete automation. In other words, everyone needs to understand my patent. But the patent is very difficult. It's one patent considers 3 innovations, not one innovation, 3 innovations. All 3 innovations are holy grails in knowledge. Okay, the first innovation is universal user interface. Everyone must use the same user interface, which is simply the tree structured multiple choice question format. Okay, why do we use that? Nobody seems to understand why we use the hypertext or the menu system. We use that because we are created with a human associative memory. Another, our mind can associate things. Therefore, we are allowed to access the human associative memory allow humans to access unlimited amount of information. In other words, you go to a library, you can find anything you want to find. Why can you do that? The reason is you have associative memory, not direct access memory. Okay, this is universal user interface. The second, universal computer source code. That is innovation. In other words, today, people program by English-like languages. Okay, universal compute source code say you have to program with integer like source code, because integer is the native language of the machine. Okay, so the US Patent Office approved my patent. Okay, Nature approved DNA. DNA is 0123. Okay, Nature approves, and the Professor Ramusi approves it. Lofty Sadeh approves it. There's so many things approves it. Then finally, the final holy grail, that's the most subtle holy grail. That is universal data file. Another, in every data file, you should contain the address of the data. So you can access this data by knowing the address. How do you know the address? You know the address by going down the tree. So you have associative memory. Again, the memory is done by the machine, by the associative memory. So humans no longer need to remember informations. All the memorization will be done by the machine, by the computer. Okay, so now we got the situation where we can build human language programming language. Okay, in other words, everyone program computer using their native language. The question will be asked in a universal user interface with the native language, Chinese, English, German, whichever language, or multimedia for people, young kids, or even animals, insects. They can look at if they can identify multimedia, they can program. So every human being can program. Over age of 6 can program. Once people start to program, the productivity will increase by so much. But to build this complete automated foundation for software costs, it's up to trillions of dollars. You see, I called the Microsoft attorney. Yes. Actually, I attended their class action lawsuit. I gave a talk. I said, software developer need to pay for the update cost of the software. Microsoft lawyers, they almost crawl under the table. Okay, they're so scared of such a suggestion. This suggestion will just ruin everybody who creates partially automated software. You see, they're so scared, they crawl under the table. Then I call up Microsoft again. I talked to the attorney. I said, well, I want the Bill to change his mind. Just don't go for it. He already got so much money. He should change it to complete automated software. Then the attorney said, I will give one last try. So that's the last conversation. Okay, so I did my best. You see, I'm an ordinary person. I'm not thinking I'm so great. I'm just
thank you.
What I feel is rational. Okay. You people hope will follow, will help me. Okay.
Yes.
In drive this, there's no selfishness here involved. Obviously, I'm going to give this away. My friend Richard Stallman tried to break down the cost barrier. He started all this open source movement. He tried to break down the cost barrier. And I'm trying to break down the technical barrier for human to use the computer. Okay. So the technical barrier and the economic barrier. So we are not totally rich, but we support Richard Stallman. He's supposed to be poorer than we are, you see. So basically, we try to do this, So we do everything we can so far, So
yes, Professor. Thank you.
Yeah, thank you. One last comment. Okay. Human on Earth automate by writing software. For software to be used for the universe, the software must be written in the form of DNA with 0123 as its source code, which is most logical, which should be written by I Ching numeral. I Ching, the Chinese I Ching. I Ching numeral, which is the most logical and efficient representation of DNA. Okay, that's all my comment. Okay.
Thank you, Mr. Adam. What you want? What you want to add today, Mr. Adam?
Thank you, Sharif. I'm interested in this subject through ethical, moral, and philosophical lenses. I don't want to overstate or be too cliched about the obvious risks that come with automation. One of the most obvious ones being the effect it will have on the quality of life of all the workers affected, including the quality of one's meaning. We'll ask ourselves, does my life have meaning? Does whatever it is that I do have meaning? Am I making an impact? Am I making a difference? Am I leaving a legacy after I'm gone that will have a positive effect on human civilization? Will I be remembered either as a good person or a useful person? And a lot of these existential questions are tied in with what it is we do: career, project, art, creativity, inventions, the magnum opus, craftsmanship. I think the word craftsmanship is relevant to this issue, especially on a more philosophical level. So if there is an explosion of automation, rapid, very widespread adoption of automation, what effect will this have on people who are working in a family business that has been passed down to them from generations back originally, for instance? And of course, that is an issue that has already been highlighted and affected, because a lot of these situations were first affected initially going back decades all the way to the beginning of the 20th century, like with the Ford automobiles and stroke of genius that was the assembly line, or even further back than that. So I wonder whether or not there will be a resurgence in Luddism, like when mill workers sabotaged machines. They were afraid of being used to replace them at the beginning of the 1800s, I think it was. And the Luddite movement started in Nottingham, in my home city, which is quite interesting. Or will Luddism dwindle into something subscribed to by very few people out on the fringe by the time automation really gains traction, since 99% of people will be so used to ubiquitous technology by then that the thought of fighting back against automation or any technological development would be almost unthinkable to most average men and women by that time. So by the time widespread all-purpose automation comes to be adopted, will the total number of humans already be quite reduced by then because of depopulation patterns? Thus, the risk of displacement, listlessness, and despondency also be far less of a risk by then. Hopefully, because of course workers who suffer crises of redundancy, obsolescence, excessively early retirement, unemployment, cutbacks, and so on, can lead to depression, anxiety, suicide eventually for many, unfortunately. Or if population numbers stay roughly the same, will there be enough replacement jobs, emerging skills, innovative new automation related skills like repairing machines, computer science, IT, coding, software development? Will there be enough vacancies in these industries that could help to prevent displacement, unemployment, and obsolescence once all these myriad traditional jobs and skill sets are replaced by machines in this coming new age of automation? And not only that, these machines may yet prove themselves to be superior to their previous organic counterparts in nearly every way. And that's another effect that could have a devastating effect on people's self-esteem and feelings of self-worth. And if not, would it be wise to then put some kind of cap on automation so that the option is there for companies to automate everything, whilst in some situations, employing a kind of ceiling on such developments if it is clear that some populations and demographics are at risk of losing their way of life if automation were to be forced upon them? But I think where money and profit are involved, such a limit might prove to be unpopular. So thank you, Sharif.
Thank you. Professor Edwards, then I will ask Professor Rob. As we're discussing about automation science and engineering, at present situations, we are facing a lot of challenges, especially, let's say, Asia Pacific, they have many manufacturing. Even in the COVID-19 situation, this many manufacturing hub and the corporation, they have to stop their operations. China and other countries, they are facing a lot of challenges. If we invest more in automation, how we can solve this problem? Like, how we can create more automated manufacturing hub, and it will help to grow our economy in the future.
Well, one of the issues that you brought up, because you brought up the COVID thing and has been discussed in this forum in the past, is supply access. And which is something that would certainly affect what a plant or factory or enterprise does. We've certainly seen supply disruptions here in the United States and elsewhere. In computer chips, for example, we're having problems right now with that. There's also geopolitical reasons. For many decades, the U.S. and China were kind of growing together. Many of our Apple computer or Apple now produced in China, but now we see geopolitical challenges about China and their what they've been doing in Asia Pacific, what they've been doing in Singapore, and so forth. And so now we have that issue added to the supply issues that we've discussed. And so I think that really has to come into play and thinking about calculations about what exactly you're going to do with a factory. Obviously, I believe that automation has been going on since, well, as we were discussing, the beginning of the Industrial Revolution. That was what it was noted for. In textile factories, instead of having women sewing things, we had machines that were doing a lot of that work. And that process is going to go on. There's no way to stop. Okay. You can't. The question is, how do we do it intelligently? How do businesses experiment with the best mix? And frankly, I don't know what the best mix is, because, as I say, there's technology coming along that may, in many sectors, make the idea of production in factories and so forth a moot point. And I mentioned the Internet of Things and the fact that we might have as many as 500 billion sensors in the world over the next decade. And so things that might have been consumed as product now are consumed as services or consumed or accessed in other ways. I mentioned 3D printing as an example of something that might completely revolutionize certain areas of production. So instead of producing, for example, maybe clothing in a factory, maybe you'll have it produced locally with a 3D printer and you get to customize it yourself. It's interesting. This particular shirt I'm wearing right now, see, it's very nice, isn't it? I got from Lithuania. And because I found a place in Lithuania and a woman who designed her own things and produced her own things, and I was able to access it. So I've got a very nice little shirt here. But the point is, I was able to say, well, I sort of like it this way and that way and a little bit more and so forth. So you're going to see those kinds of decisions made. You're going to probably see in the Asia Pacific area, for example, you might see what you're seeing more in the United States, and that is what we call boutique production, meaning that it's customized. So I think that's kind of the way to think about this in a broad sense, that if you're in the Asia Pacific area, automation is going to continue, but you have to watch where it's going to be continuing in a traditional way and is simply more adding on what has been done since the beginning of the Industrial Revolution. By the way, I'll just mention that Adam's points. Adam's right that the same arguments were indeed being made by the Luddites over 200 years ago. And of course, what happened was that mass production brought down the costs of stuff so that poor people suddenly could afford shirts. Instead of one shirt in their lifetime, they could afford a shirt every couple of years when it got dirty and wore out. The mass production is what's produced the prosperous middle class in the industrialized world, and of course has been doing the same thing in countries like Taiwan, South Korea, Singapore, Hong Kong, and the like. And you see this emerging in you see Vietnam, for example, now coming up. And so that process is going to continue. The only question is how to do it intelligently. And that's where entrepreneurs come in, because I don't have a solution. I can't recommend to a factory the best way to do it. That's where you have to really look to entrepreneurs to experiment, like Tesla has been doing, Rob discussed, and the like.
Thank you. Professor Rob.
Well, the balancing of the needs to manufacture and the needs of the workers to retain a adequate income and quality of life has been messed up a number of times during the various industrial revolutions. Typically, you have a period of time where you rush through automation. You have a lot of people suddenly out of jobs. Those people revolt, and you have kind of an ugly cycle. Though automation almost always, so far, has always won out, but for good or ill. After the formation of labor unions, we reached a kind of balance. But when I say kind of balance, the labor unions tended to think in terms of short term, not long term, and so the end result was, at least in the United States, which is where I was most active, is we lost most of the steel industry, the automotive industry almost went under, the jobs of production moved overseas. To a large extent, steel is now out of China. As a result, of course, China's a bit historic with regard to their own unique labor problems, particularly in technology. So I do concur that if you want a healthy society, you have to have a balance. You have to take care of your workers. This does mean you have to do things like reskilling and retraining. Because you dump a bunch of people out in the street without jobs, and those people are going to have a lot of free time, and they're going to be pretty pissed at the folks that dumped them. And that becomes yet another problem to solve. And certainly we've seen, even in recent years, large strikes can go off the rails. The most famous strike that I studied was the borax strike, which if you ever get a chance to look at it, that was insane. They were shooting helicopters out of the air. They were burying managers in anthills. They were calling in the military to guard water supplies. It was an all-out war. And you never ever want to see something go that far. Creating balance, assuring the process takes care of the people is important. Now, the ideal place to put automation are places where people places where people shouldn't be. I would argue that mining should, for instance, be almost fully automated because it does so much damage to the people that are doing the mining, particularly coal mining. Granted, there's a pretty good argument to get off coal entirely, but a lot of the mining is incredibly unsafe, and their robots would be most likely or most available to do the work. The issue, of course, is, and we've discovered this with some of the the automation trials and simulations we've been running of late. Nice thing about today is we actually have the ability to run trials in simulation and see what the impact will be before you roll it out and do it in production. And what these trials and simulations have kind of showcased is this need for balance, this need to put robotics where they need to go. Now, the funny thing is that the point I was getting to is there was a belief that where we would most likely automate was manufacturing line, people that are assembling stuff. And they brought out a robot called Baxter that was a plug and play replacement for a manufacturing line worker, and it wasn't economically viable. The worker turned out to be cheaper than the robot at scale, and so even though the robot could do the job of an incredibly boring, repetitive job, something that is very injurious to the human body, could do it better than a human because of the lack of medical care for the workers, that they were incurring their own medical expenses. The worker was inexpensive, and it was more or less expensive, and so the worker stayed in place and Baxter failed. And it showcases that when you're doing the analysis, you've got to capture all the elements, including the medical elements that the company isn't paying, to get an assessment of whether something is viable or not. Because failed workers, sick workers, are not productive workers either. And if you're not capturing that downside, and if you're not capturing the worker cost, you're not capturing the full economic advantage of the automation. And on the other hand, where robots were highly viable were in high price jobs, like say analysts, which of course is what I am, and that was something that was much more easy to justify because we're paid reasonably well, and you could fund robots. And so here we have a bunch of folks, analysts like me, that are running studies that were coming out and saying, hey, we could be made redundant. Let's just say my community decided this wasn't a really great place to spend a whole heck of a lot more time. As a result, so it's been kind of funny and fun to watch this process go through. I do want to comment on some of the things that Professor Ching was saying earlier with regard to universal user interface and binary languages. We do have a binary language. It's actually called binary computer language, which is ones and zeros. That's how you program. But the focus of the industry right now is, rather than forcing people to learn how to communicate with machines, which is really what we did in the early ages of computing. When we started off computing, we coded in binary. In fact, the early personal computers were all binary machines that you can programmed in 1 and 0s. But people really aren't set up to communicate in 1s and 0s. We're not wired that way. So it was highly inefficient. So we moved to our advanced languages, languages like Fortran and then COBOL, as we advance. And now the effort is to create conversational computers where people can just talk to them, tell them what they want, and the computer then does and forms the code automatically to solve the problem. Now, the belief is, and we don't have this at scale yet, the belief is that will be more efficient because rather than the human learning how to interact with the computer's learning how to interact with a human. And over time, it learns our nuances, the unique way we reference hand signals, body language, and the rest, and then becomes more capable as a result, as a peer to the human. Because the issue with binary is computers will always be better at binary or any kind of mathematical language than humans are. They are right now. And so if you're going to argue that humans and computers are going to coexist, going down a binary path will probably not get you there. Going down a binary path would be computers only, because they're going to have much higher efficiency in that kind of an environment, and so people become obsolete. Now, as we've discussed before, and as Adam brought up, making people obsolete is problematic. You have a whole bunch of unemployed people and unemployable people. And granted, you could provide services that allowed them to live and maybe live a very good life with a government income, which is what a number of people are proposing with regard to a guaranteed minimum wage. A guaranteed income. But the issue is if you're not engaging people, they don't advance and don't develop. And I think the models will show that it would just end the race. It might take a few hundred years, maybe a few thousand years, but to advance a race, you have to challenge it. And if you remove the challenges on the race, the race will eventually atrophy and die. At least that's the belief. As I say, the industry is now focused on really trying to make and I shouldn't say all the industry is that way. There's certainly those that believe very strongly that people should be taken out of the mix and we should just have computers and we send everybody an allowance and that's the way we go. I think that's short-sighted, but remember, for a lot of people, if you're talking thousands of years, they don't really care. Because they think tactically, and they're not thinking about preserving the race. So for those of us that really want to think about, hey, we want a future for humanity, then the effort really is talking about how to create a partnership between humans and machines, and rather than having people learn how to interface with machines, have the machines go more than halfway, learn how to work with computers, and then include the humans in the process, optimizing the humans for what they do best, which tends to be more creative aspects of things and innovation, and optimizing computers for what they do best, which is repetitive tasks and things that need to be done at high speed, at relatively consistent and common methods, so that the end result is a future where everybody is optimized. Humans are motivated to be intellectually engaged, and machines are doing all the stuff that humans really don't like to do, that are either harmful, repetitive, or boring, or whatever. And that's the future. We're not there yet, and right now at this particular point, it's not clear how we're going to end up, because as they say, they're clearly two distinct camps, but a lot of variance in between. But my belief is if you're going to go through and automate something and do a major automation effort, you do have to take a lot of trouble to understand what the impact is going to be on the workforce and preserve them in some way, shape, or form so that you don't have another bigger problem when you're done. And at the very least, in a lot of places in Europe, get through the regulatory process to do the automation. Because if you're displacing an awful lot of workers, there's a pretty good chance regulatory is going to sit on you and you're not going to get it done anyway. So sending all of that is very important. So I think Adam was on point.
Thank you, Mr. Dan.
Okay, there we go. Yeah, great discussion. I find it interesting that governments at all levels seem to be ignoring the big transhumanist questions. Like, we have this looming singularity potentially coming down the pike, and by 2040, all we're talking about is, maybe we can be carbon neutral by then. I mean, yeah, exactly. I mean, this is why I just love the platform of the United States Transhumanist Party, and I'm so glad to inject that into the Overton window a little bit, because I don't know if it's a problem of, supply creates demand. If the government's not supplying the conversation about the big existential risks to civilization, then there's no demand for them in the public discourse. I don't know, but like I said, I'm going to be happy to do what I can to put this into the debate, at least. If anyone's in Thousand Oaks, Human Rights Day, October 17th, I'll have a street fair booth here in Thousand Oaks. And so that's going to be an interesting presentation of some transhumanist thought. And I think civilization grew up in a way that was kind of not system-centered thinking. It wasn't planned. It was kind of an organic, extractive, random process. But now we have the chance to institute a planetary nervous system. We have the internet. We have things like geospatial information systems. We have peer-to-peer smart contracts. I mean, we need to bring these things online like yesterday. I mean, as soon as possible. I'm one of the early members of the Lifeboat Foundation. That's a great institute that talks about all kinds of huge threat level questions. Extinction, mass extinction. It's funny you say existential risk. People think you're talking about philosophy. We're talking about threats to existence, not threats to philosophy. So, I think we need to even just fix the language that we're using to talk about, big civilization level questions. I will yield the floor there.
Okay.
Hey, Dan, I'm in Lifeboat as well. I'm also one of the early founders.
Great.
Okay, great. Thank you.
I'm involved as well.
Yeah,
and
and
the Transhumanist Party.
I just want to recommend this book. It's a plan to create basically panarchy and a free society. Fierce.org is the Jeff Graubert. It's basically a spec to do intentional communities as a replacement for government. The idea of government by subscription. Panarchy, and I think we also need.
And as a good libertarian, I applaud you.
Yeah, I think soft power is not being used to the full extent it could be. Everyone's thinking in terms of hard power. No, we have all this amazing soft power. We have the internet. We have economic decisions that we make. So let's let 1,000 non-coercion flowers bloom, so to speak.
Thank you, Professor Ching. Professor Ching, can you please unmute, please? Unmute, please. Professor Ching, can you unmute?
Well, we're waiting for him to come on. I've got to run. So thank you all, and see you all next time.
Yes. Thank you. Bye-bye. Bye-bye. Yes. Professor Ching, can you hear me? Can you unmute, please?
Maybe
Yes.
go for concluding
Can
remarks.
you hear me now?
Yes.
You can hear me now?
Yeah.
Okay. Let me answer this question by Rob, even though he's no longer here. But it doesn't really matter. This is a big question. You see, I think in my patent I said that the wrong direction in computer science start with assembly language. Okay. In other words, in binary they can understand. It's understandable by machine and also at least not by human so well. But when you change the assembly language, Fortran, all this other language, it's neither understand by machine nor the human. Okay, it creates a technical barrier for non-English speaking people, and also for just this randomly picked, human language is totally, create this eventually going to create a complexity crisis. So this is the basic objection to Ron. And also the important question here for both Dan and for Adam is it raised the question of in social science. You are talking about social science. The world needs to move from money-oriented society to knowledge-oriented society. With sufficient productivity in a knowledge-oriented society, all people will have a universal basic income, okay, which derive very little return. And to compensate, to balance the low rate of return, we need to use money to support innovators, to let them make additional money. But their project need to be reviewed by forward-looking solution value, not by peer review. Okay, our Pulsar Institute solved the problem of value based on the problem posed by Gerald Bru and Kenneth Arrow. And Gerald Bru and Kenneth Arrow, they are Nobel Prize winners. They are not being accepted by the society. So basically, what Adams need is to have enough productivity so that we can have give people universal basic income. So people who don't need to be bench warmer in a company, try to work on marketing. Okay. People who have productivity, they got innovation, they should, propose it. And we do not want to use old idea to judge their new ideas. Okay, we want their idea to be judged by the solution value. In other words, we calculate how much value this innovation will produce, and we will eventually hold them accountable for these innovations, their projections. Okay, so basically judge by future forward-looking solution value, not by backward-looking peer review system. Okay, so this should be interesting to Adam and Dan, especially for Dan. He's running for political office. This is society should move from money-oriented to knowledge-oriented, and the judgment of proposals should be by forward-looking, not backward peer review. People just know each other, have some relationship, they get all the money, and those who have real creative new ideas, they all got shut down. Okay. That's the problem. Okay, I'm for transhumanism. Okay, they all asked me to join. Sure, I joined, and then nothing. I have no objection on that. But individually, on different points, I think they should still there for knowledge. Okay, that's why we are on the same path. Where I'm for knowledge. Pulsar Institute totally for knowledge. Okay. So there's another problem of worker. For Adam, for the other people, for Edward. Edward has this idea of workers, race, or Rob also raised. Rob raised the question of workers versus robots. Okay, Pulsar Institute has solved the 300-year-old unsolved contact problem. Okay, in the days of Newton. Newton say force is push and pull. Push or pull. Okay, before you can push and pull an object, you have to make contact. The hand have to make contact. Normally, if a hand make a contact with object, it should bounce off, just like a ball bounce off a racket. Okay, this contact problem, I think Robert Hooke must prod Newton on this question. How can you make contact? You cannot make contact because the hand should bounce off. In order to make contact, there's a new physics involved. And the Dai Wu is supposed to be the Chinese father of physics. And he has two new Nobel Prize winner students, and he posed the problem for them to get the Nobel Prize. Dai Wu and I solved the problem of contact, the contact problem. Once you solve the contact problem, if you implement it, it will allow robots to be as physically capable as humans. So this robot will then be able to take over all human physical labors. Okay, this question should be interested to both Rob and both Adam and Dan who are philosophical oriented, which is I deal with philosopher Paul Feyerabend and also Benson Mates. I don't know if you know him. He's the biographer of Leibniz. So I have close relation with philosophers. I like, so far our pole science is backed mostly by philosophers. They like us. And the mathematicians, they are also supporting us, but they couldn't understand us. The rest of the society is basically is completely against us. Okay. We're both a threat and the people who are not understandable. Okay, I'm not speaking for me. I only got criticized once, by the Rob. Okay, my professors, they are dismissed by half of the population. Okay, supported the Sade is the most technically famous person in the world. He's the father of fuzzy logic, but only 10% of the people support him, and the 90% people who are not didn't care for him. But I think his idea of fuzzy logic should replace the current exact logic, because fuzzy logic allow range of tolerance. A robot has no tolerance. Human has tolerance. Okay, this tolerance comes from fuzzy logic. Range of tolerance for survival. Once you are interested in survival, okay, somebody talk about survival. Okay, once you are into survival, fuzzy logic become necessary because range of tolerance become most important. It become necessary. Okay, you have to have a range of tolerance. You have to biodiversification. You have to have all kinds of humans, all kinds of species, in order for living thing to survive in an uncertain future. Okay, so the foundation of knowledge is incorrect. But the person who proposed initially is being shut down by 90% of the human population. You see, so this this problem of touch is extremely important for. You see, it's not accepted by the establishment, not by physicists, not by coaches, but you see the sport regulation for double hitting has been changed in tennis in 1982, in table tennis in 2004, golf in 2019, just 2 years ago, just a year ago. Okay, they changed the regulation. Why do they change the regulation? Because they have to have this. This is natural physics phenomenon, but it's not accepted by coaches, not accepted by physicists. They don't understand it, so they feel it's a threat. Okay, Dan can use this to question physicists and the coaches, but it's also accepted by 500 top tennis players and their coaches. Okay, all of them buy my book. So this word, there's some problem with ethics, like Adam says. There's something wrong with ethics in this society. They don't accept it, they don't understand. Okay. They also do not accept it that present a threat. Okay, I do not go out talk too much. Today, this morning, Sheriff woke me up to attend this dangerous public session, with people unknown.
Okay. Yes. Thank you. Tomorrow we have a special discussion on digital enterprise. So definitely we want to invite you all. Can I ask for other speakers, Mr. Adam, if you want to add some point with you? Yes, Mr. Adam.
This situation got me thinking about our situation, the cultural impact, the social impact, the geopolitical impact, and so on. I think the cultural impact of COVID may result in a few, for now, irreversible cultural alterations. I reckon for decades to come, there will be increased awareness and mindfulness of hygienic standards, cleanliness, clean freakism, to use a rather vulgar term, but standards may get higher and remain high in this regard. So this would affect our propensity for touch, for tactile stimulation, our hunger for textures, to a level where people will be far less comfortable engaging in tactile interaction. Certainly less comfortable with being in close physical proximity to each other as well. Customs like handshaking when greeting acquaintances, fist bumps, high fives might fall out of fashion. Excuse me. I don't think they will die out completely, but they might fall out of fashion, leading to increased demand for measures to protect against germs, bacteria, viruses, increased standards with regards to hygiene, purity, cleanliness, and of course automation is an ideal development to meet this kind of demand. Inorganic devices touching other inorganic devices wouldn't risk being a factor in the spread of pandemics and contagions, unlike flesh and blood beings like us. Mr. Robert Endeley raised another important consideration regarding automation, and that is high-risk occupations like mining, oil rigs, diving, space travel. It seems a great idea to people on the outside observing this, and it is a great idea. I do have a feeling that if we asked the people who actually do these occupations, would you want your chosen occupation, miner, oil rigger, diver, to be automated to save the lives and health and well-being of future generations of miners and divers? I think they would say no, and the members of these younger generations yet to come might also say no too, because it's hard for a kind of thrill-seeking personality to be a thrill-seeker in a world of punitive health and safety measures and demolition man style nannying. Now, as Mr. Hughing was talking, I like the idea of a knowledge-based society and economy rather than a monetarily motivated society and economy, because money might indeed become far more meaningless in a more automated world. So we addressed some downsides of automation earlier already. So to address an upside, automation could help facilitate people who are so inclined to pursue more intellectual, creative, and philosophical pursuits, learning, polymathy, etc. But of course, we need to have the necessary wisdom to be able to do this in such a world. Otherwise, we risk falling into a kind of listlessness of the soul, a dark night of the soul caused by a lack of meaning and purpose. And our descendants may struggle to realize this because people suffering conditions of the mind, spirit, the soul, fail to properly reflect and understand what it is that is affecting them because they are blinded by affluence. So to be suffering mentally from something might cause some kind of cognitive dissonance and would feel counterintuitive. People asking themselves, how can I be suffering in an affluent utopia such as this? So that would prevent them from getting at the root of these conditions. We know that affluence can, unfortunately, lead to so-called diseases of civilization, and it is also known somewhat colloquially as affluenza. So an advanced automated society like what we propose here risks sending populations down deeper rabbit holes of affluenza and diseases of civilization. So not only diseases of civilization, but diseases of advanced civilization. So like with many technological developments, we need to remember to evolve with it so that we then have the necessary wisdom and are equipped with the necessary motivations and intentions to prevent these kinds of malaise, as I just described. Thank you, Sharif.
Thank you. Thank you. This is really, really great discussion, and I'm sure it will be very effective for our audience. Actually, World Talent Economy Forum, we just finished our 338 episode. We engage with 100 different countries, organizations, university, think tank, corporations, government officials, as well as media personalities, scientists like you. And our major objective, yes, we want to develop a knowledge-based society. We want to collaborate in between developed nations and the developing nations. Developing nations has a lot of problem, but we can utilize the knowledge of the developed nations. And if we can work together, I'm sure we can minimize the gap in between developed nations and developing nations. In the COVID-19 situation, we have many challenges. In the academic sectors, we have challenges. Healthcare sector, we have challenges. Every sector, we have a lot of challenges. But I believe if we connect all of the talented peoples, and we can make a collaboration like Transhumanist Party, like Pacific Crime Business Council, like all of the universities and other corporations, we can help millions of communities. Still, there are millions and millions people around the world still is untouched. I'm from developing nations. In my personal life, I personally engage with millions of people to develop academy, and I find there are still a lot of gap in between developed nations and developing nations. But I believe, I trust, if we engage with these developing nations communities, this Asia Pacific communities or African communities or South Asian communities, it will help you a very good outcomes. That's why World Talent Economy Forum, we are focusing on developing our university initiative. Already we are developing our different kind of research, coaching and consulting related fact. The speakers, those who are ultimately the resources for World Talent Economy Forum, if you have any good idea, any good plans which will be helpful for our young community, the youth community, 40% of the population live in Asia Pacific, and they are 57 to 60% people actually youth, those who are under 30 years of old. We can maybe the people like you, experienced people like you get your maximum like a level of your careers. But if you can contribute for the young community, those who are under 30 years of old, maybe you can be the change maker, you can be the voice for the youth. So that is the way we are working. We need lot of collaboration, we need lot of people for support. Yes, we are not only looking for money, we are looking for more good human resources, good technology, good scientific things, and this way hopefully we can solve these things. And today I just want to share, in India only we are supporting 1 million students. They have a projects of digital dana. So World Talent Economy Forum actually is supporting this initiative, and through this process we will engage with 1 million students, those who are underprivileged. But we believe that if we can support this kind of initiative, we can change human life. And only I just want to share, in this COVID-19 situations, only the South Asia, it has $1 trillion lost in the academic sectors. So I believe that if we can contribute this society, maybe we can get a very good returns. And the COVID situation, we can help lot more peoples, and with the better community, with the better knowledge. Yes, what actually Professor Ching said always, that knowledge is valuable, and we believe knowledge is valuable, and there are millions of people you can help them to develop their knowledge. Still there are many people, they need to know the modern science, modern engineering, modern technology. Yes, I'm also a transhumanist. Transhumanist has lot of intellectual people, a lot of scientists, a lot of researchers, and they can contribute for the global communities. So that is the objective. The government, academy and corporations, we are making a good collaborations in between them. So if you support our initiative, maybe we can solve many things, and I'm sure you will enjoy our initiative when you go offline and different kind of things. Thank you for joining today's session. Tomorrow we have another interesting sessions on digital enterprise, and I request all of our audience from around the world, those who are observing our show, please share our content as much as possible with your government, with your corporation, with your academia. Thank you everyone. I directly want to go for the concluding remarks. First Mr. Adam, then Mr. Dan, and finally Professor Ching. Mr. Adam.
Yeah, I just wanted to tell Mr. Ching I've just got my email address written in the chat box if he wants to connect.
And, great.
And I can find your email on your website as well.
I will email you. Because you will be the person who will responsible for something which the whole world will attack you.
Yeah. That's
okay. Let me tell you something. Actually, I'm just a thinker. I don't really care what society, happens. They're going to, really already lost long time ago. Okay.
Yeah.
You are talking what you are talking about. You might appreciate this. If you appreciate this, then you will be attacked by the society. You see.
Yeah,
that's you appreciate this, so it's fine. I don't. I will project to you some ideas.
Please do. Yeah, I'd love to have a read. Definitely. Yeah, I would love to. Please send everything you'd like to send. Thank you.
Basically, I'm thinking the society, humans are too self-centered. All kind of problems come from self-centered. So for the audience here, I will tell you that the human intelligence in the universe does not rank very high. Okay. That's what you are going to hear from me. Okay, so I'm giving warning to other people as well. Okay, so basically that's it.
Thank you. Look forward to connecting.
Yeah. Okay. Great. Yeah. Thanks.
Yes, yes. Mr. Adam, what your concluding remarks today? And
Oh, yeah. Well, I just this is a very fascinating topic, very fascinating subject, and I've really enjoyed talking about all these different subjects. And yeah, I'm excited to keep learning more. Just yeah, so thank you for inviting me, and it's been a pleasure to see all these meet and all these different people, listen to different opinions. So yeah, thank you.
yes, thank you. Mr. Adam actually taking care of our publications and research. So we are going for the research paper publications. He will be our fellow for World Talent Economy Forum. So yes, I even Mr. Dan and Professor Ching, if you want to support our initiative because you have a lot of experience, it will be great. And hopefully
Okay,
by
awesome.
this way, our young generations can learn how to do the scientific paper publications and other thing. Mr. Adam actually coordinate the whole things. Mr. Dan, how do you want to add, like for today's concluding remarks? And if you have any specific idea or guideline, definitely we're going to follow you. And I want to invite you all in our board of advisor.
Oh, I'm honored, and I'm very excited and pleased that I was invited, and looking forward to taking part more. Yeah, I just want to say that I'm not running as a traditional politician for city council. I'm more of a poetician, which is the party, the Pirate Party. You may have heard took over the Iceland Parliament actually for a few years. A gal named Bridget, can't remember her last name, but yeah, it's the idea of a more, I mean, not complete direct democracy. I mean, you still need experts in the loop, of course. You don't want to have unqualified people, making trivial decisions about things they're not experienced in, solving. But I think there's something called the overview effect. And it was actually predicted in 1948 by Sir Fred Hoyle. He said, as soon as the first photograph of the Earth in space is taken, it will cause this profound shift in society. And sure enough, 20 years later, the Apollo 8 astronauts pointed the camera out the window and brought back the most amazing souvenir from space they could have, which was the overview effect. And since then, hundreds of astronauts have experienced this. Not all of them have this extreme cognitive shift, but there's an Overview Institute. There's a book about it, and I think one of the things I want to do at my street fair booth is at least have a scale model of the Earth and the Moon, because Hollywood always shows it wrong. They always show the moon way too big and way too close. But the moon is like 30 Earth diameters away, and it's like 1/4 the size. So just knowing that the biosphere could be wiped off. If the Earth were a basketball, you could wipe the entire biosphere off with a paper towel. You would have this kind of green goo on the paper towel, and that would be the whole biosphere gone from the Earth. I mean, how fragile is our circumstance here? And just getting an appreciation of the fragility of that. And I think the World Citizen Movement is kind of a political overview effect. We need to use things like citizen science, ham radio. I'm an extra class ham. It's a 3 million strong worldwide community of people that do peer-to-peer communication. Esperanto was an attempt to have a universal language, and it's still, even though it didn't catch on, if you learn Esperanto, it makes learning any language 40% easier, and it's also a perfect intermediate translation base. When you're translating from one language to another, you go through someone who's bilingual in Esperanto, and you get this great idiom error-free translation. So anyway, I could go on, but just I hope you all take consciousness of this is Atomic Destruction Week, the anniversary of the Nagasaki, Hiroshima. And actually, the good news is 50 countries have signed on to the nuclear ban. Mexico, you're now legally allowed to boycott companies that are involved in making these illegal things called nuclear weapons. So spread the word on that. The International Red Cross has signed on to it. So we need to all save the spaceship Earth. We're all crew members. None of us are passengers. So have fun and get busy. Thank you.
Thank you. Professor Ching, what's your concluding remarks today?
Dan, I also have something for you since you stayed for so long, for you to be attacked by society. if you believe this, okay, let me tell you, political system progresses, you see, from kings and emperor, the most recent, which is, king and emperor to John Locke. John Locke's republic, okay, republicanism, okay, which believes that we should have complete freedom, basically. Okay, freedom from the emperors, from kings. Okay, and the Milton Friedman, in his heart, is for complete freedom. Okay, now Paul Science is against freedom. Okay, if you go out to say this, you would. Why are we afraid of against freedom? Of course, from a practical point of view, it's obvious. We have financial crisis. We did something wrong. We're not free to invest or do anything, print money. Many things we're not free to do. Okay, there are non-viable laws of nature in social science as well as in physical science. Okay, Paul Science have found one such a law, that is the solution value, which is a completely mathematically regular system, which corresponds to the reality of the price system. Okay, in other words, no person can arbitrarily determine a price, because if they assume a price, we can calculate it. Okay. And they are no longer. I predict both savings and loan for Alan Greenspan. Then Alan Greenspan told Bernanke about me, and then I predict the subprime vote for Bernanke, June of 2006. And Bernanke told me to get lost. He said he's a professor. He doesn't need me to teach him anything. But in 2008, he completely turned around. He said, anything you say will not be ignored. Okay, so I sort of guide him into quantitative easing, but that's only half of the picture for the knowledge-oriented society. The other half is to fund innovative projects. Okay, today they want to fund all this infrastructure. That's the lowest rate of return projects, but it does not interfere with the commercial, the capitalist system. Okay, so I understand that, but what they need to do is to fund innovative projects. Okay, if you are a politician, you see. So in other words, the world should move from today's republic to a new world based on non-viable laws of nature. Nobody will govern the society. Only people who can understand laws of nature should be the ones who make decisions for people. Actually, humans do not make decisions. The laws of nature make decisions. Okay? The solution value makes decisions. We do a calculation. I have nothing in it. I just put in the input from the market, then finally the price jump out. That's the price. And the danger of the price system is it's a saddle point. It's a semi-stable system. Supply demand side is stable, but in the temporal side, it's unstable. Into the future, it's not stable. So right now, we're worried about today's society, economy is in instability. Okay, in scientific terms, instability means it's going to grow bigger and bigger. Okay, now we're already in it. There's no turning back. If you want to turn back, it would cause lots of suffering. So we are in a really terrible situation. So, as sheriff say, I go dancing. Okay, I leave them alone. Okay, suffering or not suffering, it's their problem. But if you want to run for political office, then I will let you know. And you should share the suffering like Jesus Christ, like Socrates. don't get yourself killed.
I've lived a good life.
Thank you.
I give you both sides. You choose a good life,
yes,
and you choose suffering. Okay. What I do is I choose good life during the weekend, 3 days.
Yes.
Okay, I suffer with, I share the misery with everybody during weekdays. Enjoy you guys talking about
Professor
this.
Ching.
Today is Thursday, okay? Today's morning is still suffering time, okay? So let's suffer, okay? You know,
Like Professor Ching,
my
do you want
picture,
to?
if you see my picture, you see I really, you know, have another side, which is enjoyable life, okay? So
Yes.
basically, that's it, yeah.
So you want to share your dance with our audience?
For that.
Yes. Yes. If because we have many young like people, maybe they do like, or you want to dance with us, or you want us how to. I do not know. I do not know how to dance, but I don't know. Our other speaker, Mr. Dan, or other people, maybe they can know how to do it. Yes. Thank you. This is actually really great sessions and many. It's
Let
really
me
good
comment one thing
discussions.
on this dancing, okay? People who want to join pole science has to, when the ball comes or you drop a ball on the table, you hit it. When you hit it, you have to hit it twice. Just hit twice. One smooth stroke. If you can hit it twice, take a video and send to me. I will let you join Pole Science Institute. Okay. I'm the only human being today can demonstrate a ball come, you know, from ball machine. I can hit it back with double hit.
Okay.
So
I think Sharif wants
no,
to,
we
believer is today in the world today. You know,
I think Sharif wants to
and the
wrap up.
golf people they believe this. You see.
Thank you. Yes, thank you. I just want to share Professor's dance for our audience. He's a very nice person, I know. Yes, sometimes you want to share some of the things. Maybe we like it, maybe we do not like, but his dance, I'm sure audience will like it. So thank you.
Excellent.
Bye-bye and take care. Thank you.
Great. Okay. Yeah, here's dance.
Okay.
All right.
Oh, brilliant.
Got the moves.
Where was
Nice.
Yeah, this shave off 28 years off. This shave 20 years off my biological age.
Wow.
You know.
Okay. That's really great session and really a lot of fun. Thank you, because we need to laugh even in the challenging situation. Even it's a tough discussions.
Okay.
Sometimes
Two
we have to
sides
dance.
of life.
Sometimes we have to release from the tensions. And thank you. Bye-bye and take care. Bye-bye.
Okay.
Mr. Adam, you want to add anything?
Sure. Bye.
No,
Bye. Take care.
Yeah.
Thank you. Bye-bye. Yes. Thank you for joining today's session.
Okay. Sure. Okay. Thanks for
inviting me.